Hi and welcome to Element Z3. Thank you for liking, subscribing, and showering your love. Do continue to do the same. Today we are going to look into forces in depth with gravity. As last time we learned gravity, resistance, buoyancy, and different phenomena, today let's dive deep into gravity. Our aim for today is going to be to explore the effect that gravity has on objects and how the first theory of gravity was developed. So, my success criteria for today is going to be I can explain the effect of gravity of unsupported objects, explain Isaac Newton's role in developing a theory of gravity. There's going to be a slight change for this one, this success criteria. I'll walk you through as we come across. And the last one is accurately measure the force of gravity pulling on objects. Let's start. First and foremost, if you see this ball, the teacher has just, thrown in the air, and what happened? So, what happens to this bouncy ball? Think, think, think. Nice. I'm sure you have thought about it because in my previous video I mentioned. All right. So we have these children. Okay. Let's see children what they are discussing. All right. So first one says there is no air resistance acting on the ball, so it can go straight down. Maybe one of you was thinking same. The girl says the ball falls downward because gravity is pulling it down. Okay. The another girl says the ground exerts a force on the ball, so the ball is magnetically attracted to the ground. All right. The last student says the bouncy ball falls downwards because it is heavy. If it were lighter, it would float away. All right, I'm sure by far you know which student is being giving us the proper or closer answer or the warm answer. Let's go ahead. Yes. Did you agree with this girl? I'm sure we were thinking, and that time it must have come to your thought, isn't it? So, gravity is the force that means that objects are pulled towards the center of the earth. All objects exert a gravitational pull. However, the strength of an object's gravitational pull depends on its mass. The Earth is a huge object with an extremely high mass. So, its gravitational pull is very strong. The force of gravity keeps us on the ground. Gravity also causes objects to fall down if they are dropped. Okay, let's discover. Now, this is Isaac Newton. Do you have any idea why he is pictured next to an apple tree? Of course, we all know his famous story, right? The apple fell on him, and that is how then he came to an idea of the gravity, why did it fall, and all, right? So, Isaac Newton famously developed his theory of gravity when he saw an apple fall to the ground from an apple tree, right? And gravity fact sheet. Isaac Newton was an English scientist and mathematician. He made many discoveries in his lifetime. One of the most important and influential discoveries that he made was the law of gravity. Newton was born in 1643 at Woolsthorpe Manor in Lincolnshire. He worked hard at school and was accepted to study at Cambridge University. He worked there for many years. But in 1665, the plague broke out and he was forced to move back to Woolsthorpe Manor. While Newton was in the garden at Woolsthorpe Manor, one day he saw an apple fall from a tree. Some say it fell on his head, but there is no evidence that this definitely happened. The sight of the apple falling down from the branch of the ground inspired Newton to think about the way it fell. Years later, he told his friend William Stackley that he wondered why the apple fell down rather than sideways or upwards. He concluded there must be a drawing power in the earth, that the sum of the drawing power must be in the earth's center, not in any side of the earth. Newton spent a lot of time thinking hard about the force of gravity and how it pulls objects down towards the center of the earth. He was particularly interested in the way the moon orbits the earth, and he reasoned that gravity must extend over vast distances, pulling the moon towards the earth and keeping it in orbit. In 1687, Newton published his discoveries about gravity in his famous book, The Principia. His findings are known today as Newton's law of universal attraction. Newton died in 1727, but his legacy lives on. All forces are measured in newtons using a Newton meter, both of which are named after Isaac Newton. Even Albert Einstein, writing in 1927, 200 years after the Newton's death, described Newton as a shining spirit and claimed he had one of the most brilliant minds of anybody who had ever lived. Today, the apple tree that inspired Newton's ideas still grows in the gardens at Woolsthorpe Manor, now owned by the National Trust. It can be seen from the window of the room that was Isaac Newton's bedroom. To solve the questions, the sheets are going to be in 3 sections: beginners, intermediate, and advanced. You can choose your level and accordingly answer the questions. Weight and mass. People often use the words weight and mass to mean the same thing. But they're two different things, let me tell you, my friends. Okay? So let's understand how they both are different, and then as an individual unit, how do they go about? Mass is a measure of the amount of stuff inside an object and is measured in kilograms, right? So if you go with a bag, the bag has apples, right? So the mass is something you're looking for the weight of just those apples, not the grams of the bag that is being contributed. This is what they mean in a simple word, okay? So my unit for mass is also kilograms. Weight is actually a measure of the strength of gravity acting on an object. So it is measured in newtons. So we all know the SI unit of rule. When I write just the name of the scientist, that time my N will be capital. You must be wondering why it is not capital, right? But when I write the units, I write with a small n. But my initial is capital N. So kindly be careful of these units and how the capitalization does not follow when you write the whole thing, and capitalization follows when you're just writing the initials. Let's go ahead. The weight of an object is caused by gravity pulling it down. Objects with more mass have a greater weight as the force of gravity pulls them down more strongly. Now I'm sure you're trying to connect something here. Okay, good. Keep thinking. I love the way pondering is happening. Let's go next. Now, an object's mass will stay the same even if it is in a place with weaker gravity like the moon. Okay. However, an object's weight can change. Okay, the mass, okay, but the weight can change. If the object were on the moon, although it would have the same mass, it would weigh much less as the gravity would not be pulling it down as strongly. The moon's gravity is much weaker than the Earth's. That's why now you see the difference of the weight and mass on moon and on Earth. This is how we link and compare. Jupiter is a much bigger planet than Earth. So it has a stronger gravitational pull. Although an object would have the same mass on Jupiter as anywhere else, it would weigh much more due to the gravity pulling it more strongly. Remember, okay? Mass is how much matter or stuff is inside an object. It is measured in kilograms. Weight is how strongly the gravity is pulling an object. It is measured in newtons. I even told you the SI unit of weight, why newtons is in small n, and why the initials are capital N. Okay. Measure the force of gravity. You see the spring meter here? Okay. So this is Newton's meter apparently. You must have seen those people who buy newspapers and all. They have this one. Nowadays we have digital, definitely, yes. Olden times the spring one was used. The spring is what used to determine the weight. All right. So you're going to measure the weight and mass of different objects. Get ready to perform the activity. If you are a traveler, you'll see major of the traveling people, they have these digital machines nowadays, right? So you can definitely use that one as well to complete the activity. The weight of an object is measured using a Newton meter. It's okay if you don't have Newton meter, but definitely a weight machine is generally you can use. Remember, weight is a measure of how strongly gravity is pulling on the object. The mass of an object is measured using a set of scales. Remember, mass is a measure of how much matter or stuff is in the object. You can find an object's weight by placing the object in a bag and hanging the bag from the Newton meter. As you see here in the picture, it shows, right? And that is how the Newton meter to measure how strongly gravity is acting on the object. Just in case if you don't have Newton meter, just try to have the idea of how the weighing is done with the help of any weighing scale that is available. All right. If you have Newton meter, well and good. Definitely give it a try. Do you think there will be a link between an object's weight and its mass? Complete your measuring gravity sheet with your prediction, then conduct your investigation. You'll complete the table with your results, then use your results to form a conclusion. So I'm going to give you 3 different sheets. Whichever you are interested in, you can definitely use that. And suppose if you don't have Newton meter, you can definitely use the weight machine and write there in kilograms. And I know for weight we need the Newton meter, but at least with the mass that you have got, you can try to draw the inference. Going ahead. So after measuring, whatever is easy or hard, you can get an accurate measurement. Now the link. Remember I kept on saying, did you find the link? Let's see what the students have got for us. Did you notice a link between each object's weight and its mass? Just in case if you could find the Newton meter. Talk to a partner about the link you spotted. All right. Did they see a similar link? Okay. Can you explain any results that don't follow this link? Could be, isn't it? We all are different kind of thinkers. So what is coming to your mind? Let's ponder. You should have discovered that gravity pulls objects down with a force of approximately 1 Newton for every 100 grams. So, if an object weighs 200 grams, gravity will pull it down with a force of 2 Newton, isn't it? If 1 Newton is 100 grams, so 2 Newton is 200 grams. If an object weighs 1 kg, gravity will pull it down with a force of 10 newtons, right? Because 1 kilogram is 10 parts of 100 grams. Have another look at your results. Do they follow this pattern? Okay. And this is how we have finally met our aim and the success criteria. Hope you enjoyed the video. Thank you for staying tuned till end. We'll come up with more science and interesting facts and passages with the activities. Thank you. Till then, take care.